Hello and welcome back to the video lecture series on statistics for machine learning, and we are going through the different distributions, so different probability distributions. The very important probability distribution is a normal distribution, which we are going to study now. But before that, let's talk a little bit about general continuous probability distribution. So as we have already talked about, a continuous variable is a variable which can have uncountably infinite number of possibilities in terms of the values. Like discrete variables, they have a very finite number of values, but in case of continuous random variable, it can be uncountably infinite number of values. So we cannot think about a probability distribution like a discrete random variable in case of a continuous random variable, because for each of the values which can be infinite, the probability value will be very, very small, right? So we can't think about the probability for a specific value of the random variable. So what we do, we generally calculate, or not generally, we calculate the probability for a range of values or an interval of values for the continuous distribution, okay, or the continuous random variable, right? So say, for example, if I think about a probability density function, that's what it is called, PDF. So PDF is of the form fx, okay, and how is the probability calculated? So fx, say for example, for the interval c to d, if I want to get the probability, so integration of fx dx within the range c to d. Okay, so that's going to give my the probability value. So if I just represent this fx as a curve, right? So it's going to be looking like a curve like this. Again, the shape is completely going to depend on the fx, right? So if I assume that y is equal to fx is the curve, and if I express that in the geometrically, okay, so this is how it's going to look like. And if I want to look at the interval, so basically say for example C to D, this is the interval, this is C, this is D. And the area under the curve is going to be given by the integration. So whatever area under this curve, it's the value of the probability P. Okay. Now, if I just look from the end, beginning to end, say this is the beginning and this is the end. So say here the things merge. Okay. So this is the beginning, this is the end, and this is A, this is say B. Okay. So I can say that integration of fx dx from A to B is going to be what? Is going to be 1. So total area under the curve is going to be 1, because that's the total value of probability, right? Probability needs to be having a value less than equal to 1, right? So that's what it is. Now let's look at the normal distribution, right? So normal distribution, which is a very, very important distribution in statistics, is represented by the this formula, right? This formula basically represents the normal distribution. What is the formula? Fx equals 1 by sigma root over 2x. So sigma is the standard deviation for the distribution, and x is that particular random variable. And so random variable, when we are talking about a range, we have to talk about x is equal to, say for example, range c to d. So x is equal to c to d, right? So that kind of a thing. So anyways, so root over of 2x e to the power minus x minus mu whole square. So mu is the mean of the distribution, divided by 2 sigma square, right? And in case of a normal distribution, or in case of a normal curve, so this is how a normal curve looks like. It's a bell shape, right? A symmetrical bell shape, where this is the middle of the bell, and it extends from negative infinity to positive infinity, right? It extends from negative infinity to positive infinity. I think the way I have drawn it is a little weird. It is not going to be like this. So both side of this thing is going to have the same area. So here also the area of the curve from here to here, this whole portion is going to be 0.5, Same from here to the other side is also going to be 0.5. So this is how a normal distribution is going to look like. So in the normal distribution, this middle value, right, this represents the mu, the mean, and from here I can take on both sides. If I take a plus mu plus sigma, and if I take a mu minus sigma, okay, mu minus sigma, uh, the I mean this interval in both sides, the area of under the curve is going to be 0.34. Okay, so both sides is going to be 0.34. Okay, now same way, if I move a little ahead, if I go mu plus 2 sigma and mu minus 2 sigma. So okay, so from mu minus, so from mu plus minus sigma, if I just look at this range, the total area under the curve is going to be 0.68. Okay, so that's a substantial number. Now if I look at plus minus uh, 2 sigma, okay, so when I look at plus minus 2 sigma, I have, so this portion, so from minus sigma to minus 2 sigma, this portion has the area under the curve 0.14, and same here 0.14 from uh, mu plus sigma to mu plus 2 sigma. So mu plus minus 2 sigma, we have a total area under the curve of 0.68, right? So 34% plus 34%, or 0.34 plus 0.3468 plus 0.28, which is approximately 0.96. Okay, actually it is 95.45%. Same way, if I look at 0 plus minus 3 sigma, right? So that is going to have a value of almost 99, so 0.99, okay, or 99%. Actually, it's 99.73%. So that is why, that's the concept of 3 sigma. So the probability that the area under the curve, I mean, the probability is represented by the area under the curve. So from minus 3 sigma to plus 3 sigma, and mu being the middle point, the total probability from minus sigma 3 sigma to plus 3 sigma is 0.9973 or 99.73%, right? So this is a very important factor, right? Now, there is another very important thing. So whenever a particular variable is said to follow a normal distribution, obviously it's going to have a curve like this, okay? But the thing which may differ is the uh, peak of the curve, because that depends on the value of mu. Also, how much flat the curve is going to be, that is also going to be different depending on the value of sigma, right? So there is one other concept which is being added. So what is being done is on x, there is a transformation being applied, which is x minus mu by sigma. The random variable x is applied a transformation x minus mu by sigma, and that is called the z, the variable z. Okay, and that curve which is being followed by the z is a standard curve which is going to be same for any distribution, right? And that's going to have a mean of 0 and a standard deviation ranges that we have seen. So plus sigma to minus sigma, that is going to be -1 to +1, then -2 to +2, okay, +2, -2, and the same way -3 to +3. So -3 to +3, right? So this is how, this is called a standard normal curve or a Z curve. So instead of a normal curve, it's a standard normal curve. And why do we do this? Because that case we can very easily, since that standard normal curve is going to be universally the same, that's why from one particular random variable to another random variable, the things are not going to be different. Once we apply the transformation and convert the random variable x to a z, which is a standard variable, standard random variable, then we can use the general properties, right? So this is the concept of standard normal variable. So obviously, as you can understand, for standard normal curve also, the values which we had seen earlier, so the values between say x, so what we seen was mu plus minus sigma, the value of the area under the curve is 68% or 0.68. So same here. So in the standard normal curve between plus minus 1, right, the values are going to be 68%. And between plus minus 2, it is going to be 95.53 or something like that. And between plus minus 3, it's going to be 99.73% or 0.9973. A few properties of a normal distribution, obviously, the mean is mu and the standard. So mean of a normal distribution is mu and the standard deviation is basically sigma. And obviously, as we talked about, the standard normal curve is a bell-shaped, uniform bell-shaped curve, which has a peak at the x is equal to mu ordinate. And at this ordinate, the value of y is going to be the highest, right? So what's the value of y? It's going to be 1 by sigma root over 2x, right? 1 by sigma root over of 2x, right? So this is these are the basic properties of a normal distribution. Okay. So I hope that you have now understood at least a basic understanding of the random variable, the concept of random variables, discrete and continuous both, and at the same time the concept of probability distributions and the very standard probability distributions like binomial, Poisson, and normal. We'll cover some more important topics as we come back. Thank you. Stay tuned.